Doppler effect. If there is relative motion between listener and source, the frequency experienced by listener is different that of the original one. For example, suppose at t equal to 0, the source is here and it is moving with speed vs in this direction. Listener is here and it is moving with the speed vl towards listener. So in this, vl is velocity of listener, vs is velocity of source, and v is velocity of sound. Let fs be the actual frequency of sound. And suppose at t equal to 0, the source is here at that location, and it is moving in this direction. At time t equal to t, it reaches point O dash. So O dash is vst. But during this, fst number of waves are emitted from the source, because of the actual frequency is fs, and fs is number of waves emitted per second. So in this direction, suppose at time t equal to t, velocity of sound v, so sound reaches this point, and in this direction sound reaches this point. So this one is, then this one is vt. V stands for velocity of sound. This one is also vt. So the total length of fst number of waves is AO plus O dash in this direction, because of at time t will be first wave reaches this point, second wave, third wave, and so on. The last wave is here. So total length of fst number of waves is OA plus O dash. This is VT plus VST. So total length of FST number of waves is VT plus VST. So length of one wave is what? Question mark. This is the lambda. So lambda is VT plus VST upon FST. That is V plus Vs by Fs, number one. But this wavelength lambda does not depend on speed of listener. Consider two consecutive crests. This one is the first crest and the second crest consecutive. It is at neem tree location, it is at people tree. So distance between these two does not change due to velocity of listener. So this wavelength lambda does not depend on velocity of listener, but it depends on speed of source as well as direction, location. This lambda also remains same for listener. So lambda for listener is what? Using V is lambda f. Velocity of sound is V plus VL because of listener is moving towards source. So velocity of sound wave for it is V plus VL by FL. But the frequency experienced by listener is different. It depends on speed as well as direction. So comparing these two, 1 and 2, we get V plus VL by FL equal to V plus Vs by Fs. That is FL by V plus Vs equal to Fs by V plus Vs. If the listener is moving away from the source, in this case, suppose listener is moving toward this, away from listener, then velocity of sound for listener is V minus VL, and suppose frequency expressed by listener is FL dash, this FL and this FL dash are different. So comparing 1 and 3, we get FL dash upon V minus VL equal to Fs upon V plus Vs. Case 2. Suppose at t equal to 0 source is here, at t equal to t the source reaches O dash, that is this one is VST. Now this time listener is here and it is moving away from source, this way. Suppose in time interval t, velocity, speed, sound reaches this location. So this one is Vt. V stands for velocity of sound. During this, here also FST number of waves are emitted, but they are accumulated in this length only, because of first wave is here, second here, third, and so on. Last wave at time t equal to t, the last wave is here. So total length of FFT number of waves is this one, or it is Vt minus Vst. So wavelength for one wave is Vt minus Vst upon total number of wave, which is Fst. So V minus Vs by Fs. Here also this wavelength lambda also remains same for listener because it does not depend on velocity of listener, we have discussed already. But it does, because it does not depend on listener speed, but it depends on velocity of source and direction, that is location of listener. So for listener, this is the same lambda is V minus VL by FL because of, for listener, velocity of sound is V minus VL because it is moving away from source. And that time, suppose frequency expressed listener is FL. And this number 2 and this one same. So comparing 1 and 2, V minus VL by FL equal to V minus VS by FS. Rearrange the term, FL by V minus VL equal to Fs upon V minus Vs. If the listener is moving towards source, then the same lambda, listener moving this way, then velocity of sound for this listener is V plus VL, and suppose frequency expressed by listener is FL dash. So comparing 1 and 3, this one is 1 and this one is 3, so V plus VL by FL dash equal to V minus Vs by Fs. Readded term, FL dash by V plus VL equal to V Fs upon V minus Vs. Now, if we write FL by V plus VL, Fs upon V plus Vs, by considering sign convention, listener to source positive and source to listener negative, it is applicable for all the 4 cases. If we maintain sign convention, listener to source positive and source to listener negative, we can apply this rule for any of the 4 cases. Okay.